Welcome to section 2122, functions and their graphs, day 2. If you remember the class before, we looked at this section over functions and more of the algebraic side where we were evaluating functions, piecewise functions, things like that. Today we're going to be looking more at the analytical part of these two sections, analyzing graphs and all of the information that we can find from graphs. So again, we're going to be looking at domain and range. But our domain and range is going to look completely different than it did from the last lesson, simply because the last lesson they gave us exact ordered pairs. So we were able to make a list of the exact x values that were in the function and the exact y values that were in the function. Today it's going to be more of a domain and range interval. We're also going to be able to describe x and y intercepts and then again use the graph to find some function values. We're also going to talk about increasing, decreasing, and constant intervals of the function. That is where our y values are going up, where our y values are going down, and where our y values are staying the same. And then we're going to talk about what we call relative max and mins. Okay, so just as a review, we know that domain and range, domain are our x values, or we also call these our input values. Our range are our y values, or our outputs. So when we put an x value in to the function, we get out a y value. Our x-intercepts is a place where the graph crosses the x-axis. Now, an x-intercept is an ordered pair, right? Every point on the graph is an ordered pair. Technically, an x-intercept will have an x value that is a number and 0 for the y value, because if our point is sitting on the x-axis, we're not moving up or down to get a y value different than 0. This is how I would like you to describe the x-intercepts. However, in MyMathLab, they will have you just put in the x value. I'm not going to be as picky about it, but I want you to understand that x-intercepts look like this. They are a point, an ordered pair. X has a number, y value is 0. MyMathLab will allow you to put it in just like that. The y-intercept is the place on the graph where your graph crosses the y-axis. So a y-intercept in reality, again, is an ordered pair. If we're sitting on the y value or the y-axis at a specific value, our x value is always going to be 0. This slide is a repeat from last week or the last lesson. However, today we're going to talk about what these mean in relation to what we call interval notation. Interval notation is used for domain and range from graphs. Now, why do we use this for graphs? When I draw a graph and I connect two ordered pairs, whatever they may be, I'm just going to make this up. And I'm going to draw a graph that looks like this. I'm going to put a point here and an arrow here. Once I connect any two ordered pairs on an xy coordinate plane, I now am no longer able to make a list of x values and a list of y values that make up that point, because there are an infinite number of x values and y values between any two given points. So when I have a graph that connects ordered pairs, I now have to create what we call a domain and a range interval. Where does my x value start and where do they end? Where do my y values start and where do they end? What that looks like will be dependent on what the endpoints are. So an endpoint, if it is closed, like this one is here, means that my graph doesn't go beyond that point. That means I know the very start of my domain or my range. Okay? Anytime we're dealing with closed circles, we will use brackets. This is showing that an interval is closed. An open circle, we know, means that the x and the y value that make up that point do not go into my domain and range. So anytime our endpoint is an open circle, we will use a parenthesis. Now this will always show the left endpoint, and this one will always be the right endpoint. So it can be a combination of brackets and parentheses depending on what is on the left side of the graph and what is on the right side of the graph. An arrow indicates that the graph will go on forever in that direction. That means we're dealing with regions of negative infinity and positive infinity. On this graph, if we have an arrow on this side, that means my x values are going to negative infinity. If we have an arrow on that side, it means my x values are going to positive infinity. We also have those regions in y. So if I have any arrow as an endpoint that's pointing down, that means my y values start in negative infinity. If I have any arrow that's going up, that means my y values will go to positive infinity. Anytime we talk about infinity as an endpoint, we will also use parentheses. Okay? So let's look at using some of these. Domain and range. We know domain are our x values, range are our y values. When we're talking about an interval notation, domain is saying, where do my x's start and where do my x's end? You will only have two numbers or infinities in your domain interval. In our range interval, we're going to have two y values. Where do my y's start and where do my y's end? Okay? So for my domain, I'm looking at my x's. This would be x1 region, this would be x2 region. We always start with x1. So since this is my ordered pair, that is the first x value that is made up or has a point on this line segment. However, because that is an open circle, we are going to put a parenthesis in front of it. That is saying that the x value of -1 is not part of my domain, but everything greater than that will be. Then from -1 to 4, this region here, every single x between -1 and 4 will be included on this graph. I'm going to put a bracket behind 4 because a colored in circle means 4 is included. So this domain interval says every x starting at -1, but not including -1 because of the open circle, through 4, including 4, I could find an ordered pair on that graph with those x values. Okay. Now my range goes from bottom to top. y1 here, y2 here. Well, as I go up this y-axis, this ordered pair has a y value of 1. So we will have a bracket and a 1. And then every ordered pair up to 3, but since the ordered pair that contains the y value of 3 is open, we will put a parenthesis behind it. Okay. My x-intercepts, because we have no arrows, there will be none. This graph will never cross the x-axis. My y-intercept is here. Okay, remember a y-intercept has an x value that's 0 because we do not move left to right, and this one is approximately 2.5. Now on MyMathLab, you would be able to just put in y equals 2.5. Don't be alarmed, the ones on MyMathLab will all be whole numbers, you won't have to estimate. Okay. Now the missing function value, we did this the other day. Remember the number that sits here is our input value, so that represents our x. So here's where x is 4. This is the ordered pair where x is 4. So my function value at 4 has an output value of 1, since our ordered pair here is 4 and 1. Let's look at one that's a little bit different. I would like to ignore that arrow right there. I can't get rid of it. It won't let me get rid of it. So we're going to look at this arrow here. Okay, so our function domain, remember that's x1 to x2. So as we move across the x-axis, our first x that we could plot on this point is 3. And since the ordered pair there is colored in, we're going to use a bracket. And then we have this arrow here. This arrow means that my x's are going to continue to get bigger forever. So we're going to go into the region of infinity because we don't know where our x's stop, but we know they stop somewhere to the right of 0, which means they're getting bigger. They will stop eventually, we just don't know what that is. So we have to say it goes to infinity. Okay. My y values, we start down here at y1. As we move up the x-axis, or the y-axis, sorry, this ordered pair has a y value of 0. So we're going to color that in. Okay. Now, this arrow here, my x's are getting bigger, but notice that this arrow is also going up. That means my y values are also getting bigger. We don't know where those stop, so we have to say it stops in the region of infinity for our y's as well. Our x-intercept is here. That is the point 3, 0. It's sitting at the point of 3 on the x-axis, 0 on the y. Remember, MyMathLab will allow you to do that. Y-intercepts, there are none. This graph will never cross the y-axis. And our function value at 7, okay, remember this is an x. Here's where x is 7. So at this ordered pair, x is 7, its y value is 2. So this function at the input value of 7 has an output of 2. All right, find the domain and range. Okay, our domain, remember, is x1 to x2. We've got arrows here. So as this arrow goes this direction, our x's are getting bigger. As this arrow goes in this direction, our x's are getting smaller. So our domain should be negative infinity to positive infinity. The x region here, if it's going to go forever, will be negative infinity. My x region, as this goes in this direction forever, will be positive infinity. Now my range, here is the lowest point of the graph. Okay, so my lowest y value is negative 2. But as we go up this y-axis to get our y2 value, these arrows are also going up. So my y's are going to be increasing forever, which shows a range of bracket, because 2 is included, it's not an open circle, negative 2 through infinity. And we're going to look at one more. Remember, this is a parabola. Okay, we've got arrows here and here. So x1 and x2. This arrow will go in this direction. So my domain, my x's, we don't know where they start, but they are getting smaller, so they start somewhere in negative infinity. This is going in this direction. We don't know where my x's end, but they're getting bigger, so they will end somewhere in positive infinity. My range, my y1 value, this is the lowest point of the region, or of the graph, sorry. That is a y value of negative 4. We're going to use a bracket because that ordered pair that contains the y value of negative 4 is not open. It is a closed, connected graph. And these arrows that are going up tell us that our y values will be increasing as well. Okay. My x-intercepts, there are 2 of them. I would like you to put them as the ordered pairs that they are, 0, 0, and 4, 0. Remember, MyMathLab will allow you to say 0 and 4. My y-intercept, there is only one. It is also 0, 0, or y equals 0. And finally, my missing function value of f is 3. Here's where my x value on this graph is 3. This is the ordered pair that has an x value of 3. If x is 3, y has to be negative 3. Okay. Hopefully that is clear. If you need any more help, please email me. I have other resources that can help you. You can also look up on Khan Academy interval notation for functions. The next thing we're talking about is an increasing, decreasing, and constant interval. So we have domain and range intervals that describe what my x's and my y's are. These describe where my y values are going up, going down, or staying the same. Now my y values are what make the interval increase, decrease, or constant. But when we name them, we are going to name them using our x coordinates only, not the y's. The x coordinates describe, this is the interval between this x and that x that my y values go up, down, or do neither and stay the same. this is what your increasing, decreasing, and constant intervals will look like. It will look like an ordered pair. You don't have to worry about brackets versus parentheses, but these tell us between this x and this x, my y values are going up, going down, or staying the same. So we're going to use this graph. I think we can all agree, let's see if I can, good. I can get this, that right here, this is what we call the line of symmetry or the axis of symmetry for a parabola. This is where we have a different interval. Okay, so do we all agree that from here, my y values are going down? So y1 to y2 here, these y values, this y value here is greater than this y value here. This y value here is infinity. This y value here is 4. So my y values are decreasing, but the question is, where are those y values decreasing? So we're talking about from what x to what x. Well, if this arrow is going up, we know that our x's are going to negative infinity. Okay, so our y values are decreasing from the x value of negative infinity, through the x value of 2. Okay, from the x values of negative infinity through the x value of 2, my y values are decreasing. Does that make sense? I hope so. Okay, then we can change this from this y value to this y value. My y's are increasing. This y value of 4, or negative 4, I'm sorry, okay, is much smaller than this y value of positive infinity. But where are those y values increasing? Well, at the x value of positive 2, my y values will increase for every x value through infinity, because if my graph is going in this direction, my x's are getting bigger. This graph has no constant intervals. Let's try this one. We've got a line of symmetry here, 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 and here. Okay, so this is a decrease, this is an increase, this is a decrease, increase, decrease, and then we end with another increase. So again, we have no constants. There's no place where the graph has a horizontal straight line. Okay, this first interval is a decrease. My y's are going down, but where are they going down? They are going down from the x region of negative infinity, and they stop going down at the x value of negative. That's negative 5, sorry. Okay. Then at this x value of negative 5, my y values start increasing, and they increase until we get to the x value of negative 2. Then at negative 2, my y's start going down again until we get to the x value of 0. And then at the x value of 0, my y's start increasing again until we get to the x value of 2. Then at this x value of 2, my y's start going down until we get to the x value of 5. And then from that x value of 5, my y's will increase forever. So they will increase for every x to infinity. Okay, I hope this helps and this is clear. Like I said, I am available through email. There's other resources online for you to look at, so please let me know if you need some help. For homework, please complete your MyMathLab 2.1, 2.2 Day 2 assignment.